Morning, everybody. As you're joining with us, they have gone ahead, and the kids who are here in class have taken some time to write down the notes for this page and this screen and this one as well. So please feel free to pause as you need to copy down notes for here. And then pause again for here. And then right now we're going to start filling in what they remember about parabolas and then backtrack our way. Back here at the very beginning, I did tell them to go ahead and they don't have to draw pictures per se, but going ahead and categorizing the difference between basics and degenerates. So if you stressed out a lot on drawing pictures, I'm so sorry. But our goal for chapter 10 is to basically, for you guys once again, and then for everybody who's joining us via the recording, is to go ahead and see what happens when we have non-zero coefficients for each of these different terms in the standard form equation. But before we get back to that and before we fill in this screen, let's go ahead and go to vertex form of a parabola. I heard some good collaboration happening. Who remembers anything about vertex form of a parabola? What do you guys got? Ryan Krikorian, go for it.
Y equals ax minus h squared plus a. Y equals ax squared plus bx plus c.
So vertex form, and then we could have also, if you guys wanted to remember, there was standard form of a parabola, which we ended up calling this one our new standard form. This was the old standard form from last year. Y equals ax squared plus bx plus c. Our vertex form became our new standard form. If you guys remember that from last semester at all. And what does the HK stand for, guys? Now, for parabolas, either the vertex could be a maximum or the vertex could be a minimum, depending on what? I know not all of you guys had to do that worksheet because of honors versus regular, etc., but quick question for everybody just to think about with parabolas. We know what parabolas look like, right? Little swoops, there they are. Little concave up or concave down curves with the full concavity. What's the difference between when we have a max or when we have a min? What's going on? Ryan, you know.
It's either positive or negative.
It meaning what?
The coefficient.
The coefficient of what? Do you mean if I have any negatives, A or B or C are negative?
No, it's if a is a negative.
Good, the leading coefficient. So the orientation, we always look to the leading coefficient. I didn't like that tense. I'll say look instead, not looking. Look at the leading coefficient, a little bit of vocabulary there. Leading is, if you write it in standard form, it'd be that first one. So looking at the A. David, you were totally right in the sense that you said frowny face versus smiley face. So frowny face is going to have the maximum, smiley face is going to have the minimum. And then how does that correspond to what Ryan was saying? Ryan, what's going to be the values of A for the frowny face?
It's going to be negative. Or negative.
Yeah, so A is less than 0, any number less than 0, anything negative, not or equal to. If it was or equal to, it wouldn't be a parabola. Huh. What would it be if A was 0? Not a parabola, but yeah, because if A was 0, wouldn't that mean that the x squared isn't even there? And so then it'd be a bx plus c, which is just like an mx plus b, aka a linear function. Anyway, so we don't want A to be 0, but if A is less than 0, I'm going to have a frowny face, which has a maximum. And if A is greater than 0, I'm going to have a smiley face, which has a minimum. And that also helps us out with orientations. And then, do you guys remember, I said concavity, right? What kind of concavity does this one have? Up or down? Yeah, concave down. I'll just use CD for that. And then CU for concave up for that one. Okay, so that's review stuff, right? Maybe the only other thing to really remind you guys of is up here when we talk about the vertex. Something kind of silly that I'm teaching my Algebra 1 kids, but just in case it helps, because of this minus in the formula, You can think about whatever's here in the vertex for the H is going to be the opposite of what you see in the formula, whereas for the K, it's going to be the same as what you see in the formula. Something to do with transformations, horizontal transformations, backwards of what we think. If it's happening on the inside of translation or happening on the outside, it's exactly what we think. But I don't know, those are just some different ways of remembering. So how does that correspond to la 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 la? I'm not going to answer yet the why. I'm not going to answer yet the why. Why is there another form? Why is there another form? I'm not going to answer the why yet. Instead, we're going to just try to compare and contrast a little bit, okay? So comparing and contrasting just a little bit. Standard forms of a parabola as a conic, which is a more in-depth way of looking at parabolas. What do you notice about anything that stayed the same from our vertex form? Has anything stayed the same?
H minus, or x minus h squared.
Yeah, okay, so that's something that stayed the same, right? In the sense that I still have the h with my x value. Maybe I'll use my laser pointer instead. I still have my h with my x value. Hey, is that true in either equation? Isn't the h still being subtracted from the h no matter, or from the x no matter what? And then where's the k? Being subtracted from the y. Wait, that's weird. Why is the k being subtracted from the y? Do you guys know that there's another way to write this equation back here? We could have also said, check it, y minus k. Isn't this equivalent? What do you guys think? All that's happened is what? The k was what? Subtracted to the other side, exactly. So even though we're used to seeing it with y by itself, like as a function of x, we can totally move that k to the other side and say, oh, hey, okay, cool, whatever. Y minus k, x minus h, okay. So it's not that weird that the k is with the y and the h is with the x. Like, that's actually pretty normal. What's totally new and totally different? Oh, I thought you'd see it right away. I'm so sorry. What's totally new, totally different? The 4 and the p-value. What are those right now taking the place of? Yeah, exactly. So you can think of at the very beginning, for these formulas, let A equal 4p. And I know that seems completely arbitrary and completely random, except, I know it seems completely arbitrary and completely random, except, do you guys see how the p is in this little formula for the directrix? And the p is also going to be in these little formulas for the focus as well. If I have a vertical axis or a horizontal axis, and we haven't even talked about that yet. But we're trying to get this page down. This is like the main page for us to get down today on this chapel day, on this rainy Monday chapel day, on this starting of section 10.2 day. The focus is also going to use the p, and here's why. Ready? This little p guy doesn't even really have a name, at least not to my knowledge. It represents the distance from the vertex to the focus and the distance from the vertex to the directrix. That's what that little p represents. So that A coefficient, the guy who told us up or down, if I see him as 4 times some quantity, or if I take that A and if I divide him by 4, then I can go ahead and figure out the distance. If you guys want to think about it this way, you can also say P is equal to A over 4. That's also true. I said it, but I thought maybe writing it might be helpful. I can know how to get to a focus or how to get to a directrix if I can just find that distance. Now the focus is a point. Focus your attention. If you focus your attention, you're focusing it in on one single point. The directrix is a huge long line. The focus is a point, and so to get the formula for that, I could go ahead and say, all right, if I have a vertical axis, which a vertical axis is what you guys see right here. So a vertical axis would go with this very first picture that I have. That would go with my first equation here. And it's about to go with this focus I'm about to show you right here. I could say all I need to do is go from my HK, which is my vertex, and I need to go up a distance of P. So my H stays the same, and my K is going to add P. And if you guys notice, way up here in the directrix, we can also say the directrix is just the y equals, or the horizontal line, that goes the other direction, K minus P instead. And you could label that in this picture, but it's going to start to get really, really messy, so I'm trying not to make it too messy. I'm trying to spread things out a bit. But the directrix is like an actual line, a y equals line. The focus is a point. The vertex is a point. And that's how everything is related. Now that's for the vertical axis. The question is, what's going on with the horizontal axis? As you guys mentioned, the whole x minus h squared thing, that's normal. What's not normal? The y is squared. What happens if the y is squared? If this is a vertical axis, well, I better... Exactly. I better talk about a horizontal axis. And if I have a horizontal axis, a vertical axis is a vertical axis of symmetry. The fold line is vertical. I would fold it vertically, and I would get one side to copy the other. For a horizontal axis, it's going the other direction. So what I would have is, instead, my parabola going this way. Which means my vertex would still be a point, but my parabola would be oriented differently, right? That would actually be a positive orientation. What do you guys think a negative orientation would be if it was a sideways one? Yeah, it'd be going left. It'd be eating up the negative numbers instead of eating up the positive numbers. Then I would have, let's see, I would have my focus. Where would my focus be? What do you guys think? If it follows a similar trend as that one over there, would my focus be to the right or to the left? Right. Yeah. My focus would be to the right. My directrix would be to the left. Can I just put like an F for focus and a D for directrix? It would need to be an x equals this time. It would need to be an x equals this time for my directrix. Oh, hey, that's exactly what we see right here. It's x equals. And since it's to the right and to the left, I'm not adding and subtracting p from the k's. I'm adding and subtracting p from the h's. And so my horizontal axis, my focus, isn't going to be changing the k this time. It's going to be changing the h. Depending on how visual you are, some of you might want to try to get down the picture, and then the information will follow. For others of you, I know, you just would rather get down the information and hopefully the picture follows. But for just a few of you, technically, if you get the feel for where the focus is, where the directrix is, one's a point, one's a line, it might be easier to get this information from the picture than with the actual formulas themselves. Yeah, go ahead, Andy.
What is the directrix? What is it figure out?
Well, let me show you a picture of one example of a practical application of this distance p. It doesn't necessarily help you with the directrix, but it does help you with the focus. The directrix is just like the anti-focus. It's kind of just the other direction. One of the most common applications, and I think you guys saw it with Mr. Yu and I in Algebra 2 last year. He had some cooler videos probably than I even had. But the focus, one of the key applications is, here we go. I think I might have even stolen this picture from my pre-cal notes to show you guys last year. Would be like the location of a light bulb in a parabolic flashlight.
Oh, like a sound.
Or the sound one, exactly. There's the parabolic microphone, and that's where you put the microphone out on like the sports fields and things.
That's what he showed us. I'm pretty sure.
Yeah. This focus is a very specific point. That's a very, you would think random distance, and yet it's not. It's 1/4 of A from whatever that parabolic shape is, and it perfectly reflects. It perfectly reflects in a way that it has parallel reflections out of the parabola, whether it's light, whether it's sound, whether it's coming in or whether it's going out. So that's like one of the most particular or most obvious like applications of what we're learning. And I just like to think about the directrix as being the opposite of the focus. I'm sure there's more applications for the directrix, but off the top of my head I don't necessarily have one. The focus is the one I apply more. And so, I mean, just thinking about Algebra 2, this isn't new to you per se, but we are trying to get more of an understanding. But looking at this again, we are going to have a parabola when, let's see, b is equal to 0 and either A or C is non-zero, but not both. Why do I say A or C is non-zero, but not both? If A was non-zero, I'd have an x squared, but not a y squared. If C was non-zero, I'd have a y squared, but not an x squared. Why can't I have both be non-zero? If I had both of them be 0, it would just be a line, right? Because I already have b is equal to 0. So if both are 0, I'd have a line, yeah? But what if both were non-zero? I'd have more than a quadratic. Do you guys remember the most basic case of where x and y are both squared? Oh, that's a whole different shape, right? Now technically we'll learn in chapter 10, or we'll remember that we can't actually have ellipses, but to have a parabola, to have a quadratic, we just need one to have a degree of 2. It can be this guy or it can be that guy, but it can't be both. And so what we're seeing in these standard form equations is, okay, one of the key things to figure out is who is the guy that's squared. That gives us the orientation, and with the orientation, then we can start picking out our clues and identifying what needs to be identified. You guys have what you need from this page? Are we okay? Yeah, Sasha. That was me just trying to remind you that any horizontal line is a y equals and any vertical line is an x equals, but specifically down here we have, what is that c? It's that k minus p. And then what is that x? It's h minus p, but then I kind of felt bad because then I wasn't going to label everything in the picture. So like I could, but then it starts like, okay, there's the HK, and then it just starts getting really messy really fast. So I was trying just to be basic. But yeah, you could label it your more specific ones if you want. Okay, so let's get to a problem. That sound good? And we're almost done. Remember, it's a quick day. We only have like 12 minutes left. So get a couple examples done. You guys can at least start homework, okay? Find the standard form. Which standard form? Oh my goodness, we've had so many. But in this section, the standard form is going to be, well, hold on, we'll figure that out in just 1 second. Find the standard form of the equation of the parabola with the vertex at the origin and the focus at 2, 0. Okay, my strong advice, even though kids tend to always ignore what I'm about to say, but maybe you guys will actually listen, is to start with a picture. Because we need to identify which basic equation we're supposed to be using, and we have 2 different options depending on the 2 different orientations, and we got to figure out which orientation this guy's going to have before we can go forward. So, what orientation am I locked into? Am I required to use? Either a vertical axis or a horizontal axis if I know the vertex is at the origin and the focus is at 2, 0. Because vertex at the origin, but where's the focus? You see it? If you make a picture, hopefully it would kind of help you guys see, because 2, 0 is over here. So if I have my vertex, yay, oh no, in order for me to be able to make my parabola. So that's an approximation, that's a rough approximation, but the idea still remains that I have to have some sort of sideways parabola in the sense that for it to go that direction. I'm going to make it dotted because I don't know exactly how wide it is. At least not yet, not without further math, but I do know that it needs to have a horizontal axis. Since it has a horizontal axis, help me out. Who's the squared guy? Is it the x or is it the y? Yep. And so that would attach it to the y with his guy, which is k being the squared guy. And the x minus h. Now this is backwards what you're used to, right? This is backwards what you're used to. In your forms, you guys are used to the squared guy being on that side, but over here we're just trying to make it to where the focus or the directrix is our main objective, our main goal. The squared guy goes first. Everything else goes on the other side. So technically, if that's the case, actually, to be honest, normally you would have your A over here. Now that you guys kind of are getting your bearings, normally your A would be over here, then it's been divided to the other side. So actually, it's not even that A equals 4P, it's actually that 1 over A equals 4P. If we're talking about like our standard A, which would move our A actually to be down here. We wouldn't put the A before the 4, that's awkward. We'd put it that way. Because our normal A would be over here, it would then get divided, and then it would be cut into a fourth. If you really wanted to see who that P was and where he came from in relationship to what we're used to. But for right now, they're not asking all that. They're just saying, find the standard form. I know it has to go sideways to get that focus and to have that, either that microphone or that light source or that satellite receiver or transmitter be right there. So I just need to fill in what I know. Why am I going to go ahead and put a 0 in the K spot and put a 0 in the H spot? Yep. Wait, what's the vertex?
0.
Yeah, 0, 0. So HK is 0, 0. So I just throw in H is 0, K is 0 because the vertex is at the origin. How do I use the focus to my benefit? What am I still missing? I'm missing the P. It has some relationship to the A, but if I can just get the P, I basically have it done. What is P defined to be again in either of the pictures that we have? The distance from the vertex to the focus and or directrix. So what's my distance? And why am I plugging in a positive 2 and not a negative 2? Because it's headed in the positive direction. It's headed in the positive direction to the right. So my P is equal to 2. And I'm done. This is one way of writing it. And in the olden days, you might have also written it x is equal to 1/8 y squared. This would be x as a function of y, which is why everything is all topsy-turvy and twisty, because it's been flipped around. So I want you guys to go ahead with these last few minutes of class. Can you figure out the equation? I'm going to give you a quick heads up, because some people might get confused. It's changing one little thing. The vertex is still at the origin, but this time, the focus is not at 2, 0. There's a directrix at y equals 1. What does that change? Ready, set? Can you find the standard form? I'll give it to you before class time is out. Go. We'll stop here today. Pictures Change the general form if you need to. What can you figure out? I can also answer questions if anybody has them on what we just went over. For those of you guys that are online, we did just have a question about just clarifying who P is or what P is, and so just kind of clarifying it's the distance between the vertex and the focus. There was this question of like if the vertex is the midpoint. There's a P distance both directions. The vertex will always be in the middle of the focus and the directrix. But as we're looking here, I went ahead and just showed like we could have actually done a distance formula between the focus point and the vertex point. We would have gotten square root of 4, which is 2. Some people just saw it by counting the tick marks. But then I also just trying to bring more clarification. If we were trying to find the directrix, it would have been 2 in the opposite direction. A vertical line, so x equals. And that was only if we were being asked that. The kids have been working on the bottom problem. Let's check in with them and see how they've done. Hey guys, what basic equation are you using for this one? Did you switch your orientation? Did you notice that you had to switch your orientation? How else could you have gotten your vertex at 0, 0 and your directrix at y equals 1? What other way is there to have this work unless I have the directrix never intersects a parabola and horizontal directrices, plural of directrix? It's only when I have a vertical orientation. So therefore, if this is my case, where would my focus have been? If I was finding my focus, which they don't actually have me finding, it would have been at 0, -1, which means my P is equal to -1. My distance to my directrix was a +1. And that's opposite what my P is, which is going to be a -1. And then I would have just put all my other pieces together, meaning I would have had my x minus my vertex of 0, 4 times the -1, y minus 0, leading me to x squared equals -4y.
So the directrix is always positive?
Not always positive, but this one was, which had it heading the opposite directrix, the opposite direction of the focus, and the focus is who establishes the P. So it's the same distance, it's the same number, it's 1 in this direction, but the focus is 1 down, and so therefore I have to have that negative. Just kind of helping you guys clarify that P is the distance to the focus and the opposite would be in the other direction. So if it helps, actually, we could put little negatives on this to say the negative P would go the opposite direction to the directrix. The other version of this would have been -1/4 x squared. But that's the old school way. We're doing things the new school way. All right, kiddos, we do get to work on this more tomorrow. We do get to work on this more tomorrow, but we've got a good start in on it today. Chapel is basically, I think, same seating as last time. I don't think the set has been broken down, so basically get in there as fast as you can and grab a seat. Hopefully in the bleachers, but maybe sitting down. Oh, sorry. I was trying to turn it off. Yeah.
I've had like a note
I know. So what can I do?
I will probably have time to do it maybe tonight or like probably better tomorrow.
Do we think you might 10.1 or do we need to go back to chapter 8?
I mean, okay, well, I haven't done the review, but